Hello everyone and welcome to the mouse instrument. This is our pride and joy. It is a very big instrument, about 5 meters long, and I'm happy to take you past all the components. So here we are at the beginning of the instrument. We have two X-ray sources with slightly different X-ray energies. We have a copper X-ray source, which is the one that we use the most of all. It's got the highest flux. But whenever we have samples for which copper is a problem, so thicker samples or iron-containing samples, we can switch over to the molybdenum source, and that is a higher energy of X-rays, so you can get through more material, or you can avoid those fluorescent edges that otherwise would disturb your X-ray scattering. We can automatically switch between the two sources because it's on a motorized platform. It can move back and forth, and yeah, we can program this to do. We can program this to be done automatically. Right behind the sources is the collimation section. This, in our case, this is relatively short. It's about a meter, 1.2 meters. This has three sets of slit blades, one here, and one here. And with this, we can chop down the beam to a nice size of between 0.2 and 0.5 millimeters. We don't really use any of the larger sizes beyond 0.5 millimeters here. We want to keep our beam nice and tiny. As you can see, we have reserved some space underneath this collimation system for experiments and for liquid handling. So whenever we have liquid samples coming in, instead of putting them in a capillary, sealing them off and measuring them in the sample chamber, we put them outside here and we pump the liquid from the reservoir through a measurement cell and back into the reservoir. So that way we have a good average over the entire amount of liquid in the reservoir. So let's take a look inside the sample chamber. So this is our sample chamber. It is very large, as you can see. It has lots of space inside for all kinds of experiments. Let's open it up. So inside the sample chamber, you will see our standard stage, which moves up and down and sideways for our samples to be put on. This is mounted on a set of kinematic feet, so we can move the whole plate. We can lift it up and move it forward or backward, wherever we need it. Okay, and it just snaps back in place. We have, at the moment, we have our liquid cells standing to the side. So this is, as I said before, this is the cell, these are the cells that we pump our analyte mixture through whenever we are measuring liquids. We have normal capillary cells, which look like this. It's a little bit sticky taped at the moment, but we're upgrading our system as we speak. And we have a low noise flow cell, which is this one, which got silicon nitride windows, so it's very low background for samples that scatter not so strongly. Put that back in place. All right, our standard XY stage is where we put most of our samples on. For this, we have our standard sample holders. This can hold 3 slides with up to 5 samples each, and this can then be put on the foot of that sample stage. As I said, we're upgrading this. We're going to put a larger XY stage on with sample plates that can hold up to 48 samples for an entire rack. So that will keep the instrument busy for a good 2 weeks. Inside the sample chamber, we also have a camera. Actually, the camera is looking down onto a mirror, so we can look directly along the beam, which is perfect for aligning our samples. Apart from that, we have the detector sitting right behind the samples at the moment. I've moved it forward so we can see it. When we look down into the sample chamber from the other side, you can look somewhat into the flight tube as well, where I've driven our detector forwards so that you can actually see what that looks like. The detector sits on a 3-axis motorized stage, so we can move it backwards and forwards. You can move it close to the sample when you want a wide field of view, and you can move it far away from the sample when you want to focus on the small scattering angles. But we can also move it sideways. So in particular, when you're close to the sample, if you want to get even wider angles, you can move the detector sideways to focus on particular diffraction rings. And get a nice extension to your scattering angle range. In front of the detector, we also have beam stops on a motorized stage, so we can move the beam stops out of the way very quickly. So all of this is motorized, and that means that we've spent a lot of time trying to automate everything as well. So when we are measuring samples at the moment, we measure samples in at least 4 different configurations, sometimes 5, with different distances between the sample and detector. And then later on, after data processing has happened, we can merge all of this data together and get a very nice wide range information on the microstructure of your samples. So that was a brief overview of our instrument. As you can also see, we've started to heavily modify this instrument. We've taken away a lot of the pretty cowling which was around. We've started putting some extra flanges, extra feed-throughs in to run more and more varied experiments. In addition, we've been adjusting the software and we've replaced this largely with our own scripts at the moment to give us better measurements with more metadata. So yeah, if you're interested, leave us some questions and we'll be happy to answer them. See you around.